Because I saw it and it looked cool and I decided that I want to show it. But you want me to keep showing. So.
I mean, there's a lot of people that are showing up. That's the problem.
Yeah, but you want me to keep showing up.
Yeah.
Of course, we want everybody to keep
Okay,
showing up.
yes, I want you to keep showing up. First of all,
Convince me.
okay, this is a fun time. Time well spent. If you just want to hang out, solve some cool shit, then you're welcome. I have a little bit knowledge in algorithms, a little bit more than like usual person here, because I studied algorithms for like 4 years in high school in Russia. I won a national competition in Russia. I got a scholarship based on it, also
Here?
in Russia.
Oh.
No. Then Putin fucked me up and now I'm here. Right. I escaped my country because of the war and everything, blah blah blah.
Story about it.
Right? So extremely impressive. I know a bit of algorithms, I want to share this knowledge and I want to hang out, right? That's pretty much it. Okay. After this incredibly expressive explanation of my life, let's start with binary search, right? Okay, there's a GIF that means absolutely nothing. You don't have to look at it. Let's look at the board, right? We have a task. We have an x, we're given an x, and we're given an array, right? Let's say that x is 6. And we need to find the first number in the array that is strictly bigger than x, right? Any idea how to do it? Oh, also we have another thing. The array is sorted.
The first one?
First one that's strictly bigger.
And it is sorted?
That is sorted, yeah.
Yes. I guess it's a beginning and up until I get one.
Yes, that's a very good way to start. Anyone know what's the time? Time complexity? ON, true. Right? First, try ON. It's alright, we can do better. What's bad about this solution? Well,
It takes over.
it's not necessarily a bad thing.
But if we were to be given a huge, I'm getting the array and the number, right?
And then it's sorted already.
Yeah, a solid array and the number.
Yeah, yes.
Okay, so the worst time is the size of the array, which is bad.
The bad thing here is you didn't use the fact that it's sorted anywhere. We're missing information, right? How can we use the fact that it's sorted?
You can skip some amount of numbers. Given that it's sorted, you can start by the middle and you know that everything's relatively going to be smaller and the
Right.
right is going to be bigger.
Right. We can start from the middle.
I mean, it's also on the screen.
Okay. We check the middle element. If the number of the elements in the array is even, it's going to be like, we can check still this one or this one. It doesn't matter, we're going to implement it in the code later. But right now, just imagine that it's an odd number of elements. This is the middle. So if this element is less than x, what can we tell about the position of x in the array?
It is less than x?
It's less than x, for example.
Yeah. So we go
Right, x is to the right of the middle. Otherwise it's to the left. Right? What we did, we took our array and we cut it in half. Right? It's great. So now we have half of the array. Well, 6 is less than 11, so it goes to the left. Right? And we're going to keep doing this until we have a segment of the size of 1. Right? There's some number. Do you guys understand why it's going to be the first number that's strictly bigger than x? Is it obvious?
again.
Like, we repeated this operation multiple times until we get a segment of size 1. Right? Is it obvious why this element is the one we searched for? It's the first element strictly bigger than x. Is it true?
Well, I guess so. We keep, like, I don't know, I don't keep a way of telling if we have an array
right. Like every time we shrink our array, we choose the part where our element exists, right? It always remains in this chosen area. So even though this area is very small, it's still in it. And since the size of the area is 1, it's inside, and this is it. We found it. Right there. So any questions why this is true, why this works? No.
Can you close the door?
Sure. Yeah. Now we all know that the time complexity is logarithm n, but do you know why?
We each time we cut the size by 2, so that means that we will have to cut that's 2 to the power of 1.
1.
I. Sorry.
I. We have to make the I steps.
Yeah,
True.
equals n. Not equal 1.
Well, why does it equal 1? Let's look at this way. We have n elements, and we divide it by 2 I times.
Yeah.
Sure. And then we get 1 in the end.
Okay. That's
So like n is equal to 2 to the power of I. We take logarithm of this, and everything works. Right? I equals to log n. So I is the number of times we make our move. Okay, good, cool. Do you guys want to write it in C++?
Sure.
Writing this is a bitch. I'm gonna be honest about it. So I'm gonna need your help, right?
We did it.
Nah, it's another one. Okay. Let's read our data very fast. Okay, what did I do? Mxn is just a constant. It's a big ass number. Doesn't matter for us right now. We have array, we have the size of the array, and read the size, read the array. Same thing as in the homeworks, right?
What is C?
Right, you don't know it's C++. It's the same as scanf, but like way easier to use. We just read an integer, one integer, or like any other.
That's arguable. It's easier to use.
I don't know, I like it better. Okay.
So we just input n numbers.
We also, yes, we input n numbers, and we also need the x, right? So what do we want?
What did that line do?
This one.
Yes.
It's just we read n, and then we read x.
Oh, okay.
Just 2 integers, right? Yeah. And then we read the array one by one. We want to
And is the size of the array?
size of the array is n.
Okay.
Yeah,
So we
yeah.
get that from the user, and the x we get from the user.
Yes, we are the user here, right? We just want to
Yeah.
try it out. We want to output the index of the first element of the array that is strictly larger than x. I cannot spell. Yes. Strictly. Okay. What do we need?
Well, I looked at the GIF, and it makes sense that that is. So we need a pointer that, basically 2 pointers that bound the area that we're looking for.
Right.
They start at the start and then the end of the area at the start.
Very true. Okay. So, what are the initial pointers?
The start pointer points to the start of the array. And
Okay.
to the first element. And the right pointer points to the last element.
To the last element. That's one way to do this, but I'm gonna do it a bit differently. the right pointer will be pointing one element to the right. Like it's gonna be like this. You know this from the
Yeah,
map?
yeah, yeah.
It's like R is not included. So this is
Yeah, but if it's the pointer to the end of the array, so shouldn't it be n minus one?
we use like half segment because it's easier for implementation. We
Yeah,
just
but
remember
if
that
you-
R is not included. That's all.
So that means that the actual pointer will be r minus one.
That's
when you
true, yeah.
use it?
Yeah. If we know that L and R are our pointers, then the actual segment that they represent is this one, from L to R minus one. Right? Okay. So we need a cycle, right? We need to do this while the length of the segment, remember this one, while it's bigger than one. How do we write this statement?
L plus r.
Plus L plus R. Okay.
We're gonna, we have then divide it by two.
No. For now, we want our cycle to run while the length of the segment is larger than one.
Oh.
How do we calculate the length of the segment?
L minus
R or L?
L minus r.
L minus R.
Is it R minus L?
Right. Fair point. Do we need to plus one here?
No.
Yeah. We don't. While the size of this segment is more than one, we do this. The moment it's one, we found our number, right? And the cycle breaks.
What if you don't have a number that is larger?
That is a very good question. Yes. We always imply that the number we're searching for is inside the segment. What if it's not? We get an infinite cycle. That's very good. We always need to check that the first element of the cycle fits the condition. Why the first one? Because the
It's the smallest one.
yeah, it is the smallest one.
So you sort it like
Yeah, very true.
I mean, this way you don't check three elements, but you still have the chance of the last one still being smaller, no?
Again?
Like, if you, what you're searching for is
If
the
the
next
array ends
smallest.
at 5.
No, okay, it makes sense. Okay, now you are looking for the smallest, next smallest number to the one you're looking for, right?
If it doesn't exist, yes.
If it, no, but like the general idea,
You're right. We're searching for the first element that's strictly larger.
strictly larger.
Yes.
Okay, so if you're looking for this, if it's smaller on the first one, if it's also smaller on the second one, you are going to continue until you're done, right?
Again?
So you're looking for the next biggest one, right?
Yes.
What you said is you check the first to see if it's smaller, which
Yes.
makes sense because if it was bigger, you would already be done. But if the last one is also smaller, then it's also an infinite loop.
If we check the first one, look, if the last one is smaller, then eventually our left pointer will come to the last element of the array, which is like fair. We need to check this again as well. Right, you're right.
I mean, it's double the checks, but
Double the checks. Yeah. You guys are correct. We need to check the bad cases, right? So if the first element is what do we want? If it's already bigger than x,
and we just return, I guess that we're done.
right? We just return this element. Oh, we want index, right? We return the index, and we're done. Cout is like print. Okay. If there's like, if the last element of the array is smaller than x, then there's like no element in the array that we're searching for. right? Oh, actually, you guys, I lied to you. We actually don't need this one. Do you know why?
Because we will eventually.
Yeah, we will always choose the left segment,
Mm-hmm.
right? Because the middle will always be bigger than x, and we will always go left.
I mean, technically it's an optimization because then we don't need to do.
We don't need to check, right? We'll always go left, and we eventually will come to the first element.
We don't
So-
need to, but it's cool.
We don't need this if, but we need this if. If there's no element that we search for in the array, we just cout no answer. Return 0. Return 0, everyone knows what return 0 is, right? Yo, mate, what's your name?
Ido.
Ito.
Yeah.
You're Ina's brother.
No, that's
Oh.
Eitan.
Ita, sorry, I'm Artem. Nice to meet you.
You did.
If you have any questions, like, don't be shy, ask it.
Yeah, it's okay.
Okay,
Yeah.
so we checked the bad case. We're back.
Ah,
Okay, we checked the bad case. We're back in the loop. We want to get our middle element. And we are getting it by this formula. Now, there's like a bad thing to consider here, which is like, if we have an odd number of elements, we will get the middle element. But if we have even number of elements, what will this line give us?
It'll give the
The left.
previous
The left
left.
one.
The left one. Right. Is it bad?
no, because it's smaller always.
Yeah, you're right. It doesn't really matter. And also, yeah, well, it's fine. It's not going to give us any bugs. Okay, now we check if Ri of m is smaller than x. Then we choose, which part do we choose? If the middle is smaller. Right one. Right. So we move our left to the middle, or we move our right to the middle. And then we just return left. Any questions?
This is just quick sort. No.
No,
We don't sort anything.
No, not quick sort. No, it's not a sort. It's a quick sort.
Then you need to check if it's equal.
Okay, any questions, guys?
No, you need to check if it's equal. If it's equal.
Equal?
Yeah, if the
we don't
middle
really-
is equal to x.
We're not searching for the one that's equal to x. We're
Oh,
searching
okay,
for the
okay,
first
okay.
that's larger, right?
Okay, okay.
Norm, all good?
Mm-hmm.
Cool. Let's see if it even works, right? And it doesn't because we include some scary library.
It's an STD.
You're funny.
Oh wait, I just got that. That's funny. Wait, why doesn't it work?
Okay, now.
Yeah.
So much evil in such a small brain.
What did you say? That was a difficult
We don't support sexist jokes here, Thomas.
He does.
Okay.
one.
Okay, you guys want to come up with an input? We can just do this one. It's like,
All the uneven numbers from 1 to 17.
yes, that's how. That's all my imagination could come up with, right? All uneven numbers from 1 to 17.
Can we add a generator, like of a huge array, and then compare that to the
I say
naive
we-
approach?
I say we use ChatGPT.
No, I
Right.
think we don't touch ChatGPT.
No. You create.
Oh, just for generating the data.
Yeah.
I will allow.
Thank you so
Otherwise-
much.
Otherwise, I veto it. I gave it.
Okay, let's see what we got. let's see what we got. We put this array in, we're searching for 6. The first strictly large element is 7. It's like 0, 1, 2, 3. We got the wrong answer. It's not working.
What were we looking for?
We just add 1.
6?
That's a good solution. You guys can see that? Wait a sec.
Can you see out what the
No, we
index
can't
might
see
be
it.
as well?
Yeah, well, we should get 3, right? But like this is the way to find the last element that is smaller or equal to x.
Smaller?
Or equal. If we want the one that's strictly larger, we just return the next one, right? Okay, that sucked, and I'm sorry about that. But like, you guys understood the general idea of binary search, right? This is just the balls of implementing it. It just comes with practice, whatever. The general idea is understood, with like everyone understood. Okay. Oh yeah. The users, yeah. Okay.
So this is for the whole thing. This is for the present.
Presets.
And this is for like.
Let's do this.
Not too much.
Yeah, that's good.
Okay.
Maybe.
Can we... Oh, you got it working.
Somehow.
Can we take a break on the gun for a bit?
What's most guy?
Your connection.
Yeah, sure.
Yes. Where?
It's here. I don't know.
I thought literally the first word you learn in Israel.
Well, not me.
Depends
Fancy.
if you get in summer or not.
What?
Depends if you get here in summer or not.
Well, fair enough, I guess.
I think.
My Aliyah was in July, so...
Wait a second.
It resets for some reason.
It's because we are.
Moving? You think it's like tracking us?
What do you want to do? What are you trying to do?
To make the piece of shit from me.
Oh, is it?
Yeah, here we are. Oh.
It is tracking you. That's an overkill. Oh, you're touching it. Okay.
It kind of works.
I mean, we can just do...
If you let it's fine. If you let it go, does it go back?
Yeah.
No. We can just do like this.
Yeah.
And then it resets.
Oh, fuck you.
Why the fuck does it do that? It's so retarded. Also, the camera isn't that good.
No, we didn't.
Okay, maybe for next time, right? It's anyway. It's better than it was anyway. You surrender?
Oh, no, I'm French.
Look, he's even wearing white. Sort of.
It's really living its own life, though. Yeah, maybe it's gonna be good. By the way, if you guys sit down and I'm the only one who's moving, it might be fine.
Yeah.
Okay. Right. Let's solve a fun one, a simple one. Do you know what code forces is?
Yes.
By the way, this thing is actually asked on interviews. You gotta use this in your code, in production code. Without it, your programs are like slow and everything.
You ever seen production code?
Actually, no, never. I was told. No, I mean, at some point, somewhere deep inside, they actually use this shit.
In good companies, yes.
Yeah, maybe.
Russian production.
I mean, if you're working on like
Okay.
customers, nobody would use this shit.
Who wants to read this? I don't want to read this.
You are given a sequence A. It's a sequence consisting of n integers, where the ith element of the sequence is equal to ai. Oh no.
Oh no.
We're also given two integers x and y, where y is bigger or equal to x. A pair of integers is considered interesting if the following conditions are met. One is bigger or equal to I, which is smaller than j, which is smaller or equal to n. And is what?
N is the amount of integers.
Sure. If you simultaneously remove the elements of the positions I and j from the sequence A, the sum of the remaining elements is at least x and at most y. Due to a process that determines the number of interesting pairs of integers from the given sequence A.
So somebody understood something?
What the fuck is your
Can
anomaly?
we take like an example like this? So let's say we have
I mean, aren't you given one example?
5, 8.
Are you given an example?
There are examples, yeah.
Can I erase this?
Yeah, sure.
So, you're given x and y.
Yes, that is not so.
It's alright. We don't judge here. It's Israel.
So we have to use this for implicitly. Okay, so can you scroll up a bit?
Up or down?
Right, we're giving sequence A. This is A. And it's 4. We have 4 integers.
Yay.
Ith element of the sequence is, so this is A0, A1, A2, A3. Sure. X and Y we're going to, so let's say X is 1, and Y is 10.
So basically, let's imagine you chose two numbers out of the array, different numbers. You cannot choose the same one twice. And you want to find the amount of ways you can choose these two numbers such that the remaining sum of the array is at least x and at most y
The sum of the whole array?
of the remaining array after you delete them.
1 and 8 would be interesting because you remove them and then 2 and 5 are between 1 and 10.
Yes.
2 and 8 are interesting. 5
Um,
are interesting.
So we can just do n square,
2 and 5 are
right? Brute force two different elements and then check that the remaining sum is between those two numbers. How do we do that, by the way? After we removed two elements, how do we count the whole sum?
Is A sorted?
Nope.
You can either do the naive approach and sum everything, or do the smart approach, sum everything and just take out the whole.
Fair. So somewhere in the beginning, we're just going to calculate the sum of the whole array, and we're going to subtract two numbers. But n square, is it going to work, you guys? N square? What do you think? Do you understand what kind of numbers we're aiming at? Let's go through this again real quick. So we want to have like at most 10 to the 7 to the power of 7 operations. It is like 10 million. Maybe if we're like lucky, 100 million, right? Anything more than this is not going to fit into a second, right? I think we have like more than 1 second here, but it doesn't matter. 2 seconds.
Memory, 156 megabytes.
Oh, nobody cares about memory. Don't read that.
Production code.
You're not gonna let it go, are you? Yeah, it's all right. 2 to the power of n is this number. If we put it in square, it's gonna be like something along 10 to the power of 10, which is way bigger than this. Not good. N squared doesn't work. Okay. Ideas?
So, wait, is the array order or it doesn't have to be?
Array is not ordered. Random array.
So, I mean,
Uh,
we can order it and then choose which would be n log n and usually less than n. So,
okay, what do you propose? We order it and then what?
we order it and we can, I mean, obviously either the last two, wait, we need to return the indexes.
No, the number of possible indexes.
The number of possible indexes?
Yes, number of ways.
The number of pairs.
Yes.
So why won't we just, sum everything up
Mm-hmm.
and then sort the array?
Yes.
This is
And
also what
then-
I search.
And then?
And then we can actually
Now you take your time.
to the power two.
What's the row after? And to the power
So
two?
what was the solution that I was suggesting?
It was n square.
Was that
What was the second condition? Interesting numbers.
Uh,
One is that the sum has to be between.
they are different. And like,
The indexes are different.
yes.
So what I would do would be sort the array,
Mm-hmm.
and then you have to sum it, which is n, sorted, which should be n log n, and then do a binary search to find, like, if you have the sum and you have x and y, you need to find, it also has to be bigger than an amount, right? So it doesn't really work that easily.
There's just two numbers, two conditions between which the sum should be, the remaining sum.
So, I mean,
You guys are thinking, right? We should sort it, right? Let's sort it first. And we need n log n time. There's not too many options, right? Because 10 to the power of 5, where is it? We know that there's 10 to the power of 5 elements. In general, the asymptotics can be like, what? N square, n log n,
log n is less than n squared, but yes.
and square n, also possible. And square n is not going to fit in 10 to the power of 5. There's some fun and actually very ugly. Everything that works for n square n is very ugly. But yeah, out of all these, this one and this one are the only ones that fit. But solving this in n seems like pretty hard. So let's not do that. Let's try to do this in n log n. We sorted. And Gleb just got it. What's up?
Wait. we sort it and then we iterate over each number, and then for each number
The problem is that iterating is slow.
we do a binary search for the number that qualifies as its
No, but
Yes. Very, very, very close. Right? So now we need to find two numbers. It's hard. Let's make it easier. Let's find one number. One is fixated. It's going to be a for loop and operations. And another one we search. For example, this one is fixated.
But how does that handle if we have multiple numbers for each first number?
We'll get to that. I just don't want to use the yellow one. I don't know why. I'd rather walk. Wait, did you say that's racist?
Yeah.
Come on.
Is it not practical?
Not really, no, thank you. Okay, so we have a left index fixed. It's 1, but let's say that it's what? It's y.
Right.
We know that.
Let's make it I because y is the biggest number.
You're right. Let's make it just something very stupid, like f.
Oh, we have a f, sure.
Yes. We know that the whole sum. No. the whole sum minus f minus array of j, which is j is all possible indexes, all pairs to our number, should be bigger than x and smaller than y. We know this. So far, so good? Cool. How can we transform this equation? Well, we know the sum, we know the f, those are given. Let's leave only the unknown value, the array of j, in the middle. So we'll have x minus sum plus f. In the middle, we have array of j. And to the right, we've got y minus sum plus f. What's going on? Does it look like something? And the array is sorted, remember? We sorted it, and then we're going the left.
Also, sorry, we can use the first algorithm that we built.
The binary search. Yeah, we can use the binary search to find the first J1, that fits to this if, and then second J2 that fits to this if. What do you know about J1 and J2?
So
Okay, it's just J1 is smaller than J2. That's what I mean. That's obvious. So if we do this,
everything in the middle should be.
everything in the middle counts as a valid pair to F.
Because we sorted a grid.
Yeah. So using bin poisk, I'm talking in Russian. It means that I'm really cooked right now. Okay, we're using binary search twice, and then we subtract the indexes.
That's two log n, but it's still.
Yeah, we don't really care about the context, constants in the complexity, right? So we just log n.
Yeah, and because we're going over the entire array one
Yeah.
by one,
Yeah.
that is why we are actually having n.
And log n. Yes, fine. Let's write it. Because I like pain. Hell yeah. Shit. Okay.
Sounds like any good program.
Does the camera what? See anything?
They see it on my screen, so it's fine.
No.
No, but the camera is covered.
That's a good point. Good point.
Yeah.
There's yeah. Thank you. Okay. Oof. Input data, the T. So the site is actually going to give us not one test, but T tests at a time. I do that a lot. It's just something we need to write. Okay, solve will be our function where we write our code. It's like one input case, right? What do we need? We need n, we need x and y, and we need the array itself. The limitations are 2 to the multiplied to the 10 in the power of 5. So it's like I already have this constant, so it fits. Yeah, this means like 200,000. We read n x, no. Okay, nxy and the array. Cool. Now we need to sort it. We can write it by hand, huh?
You sort for the win.
You want me to write the sorting algorithm?
No, just put Q sort for the love of God.
You sort. Uh,
Great sort.
this is the syntaxes of C++. It's like pointer. Array plus n. It's you know this? Array is in fact just a pointer to the first element, and plus n is like to the last element. So we sort it, and I think we need to include some stuff.
Yeah, it's fine.
Is it the Y?
I love it.
I actually don't remember which one. Do you guys remember which library it is? Yeah, actually me neither, dude. I have a feeling it's the one I deleted earlier. Yeah. You think it's?
Yeah, it's in the STL, so it's.
You think it's? Let's.
If it's an STD, then
We don't need to include anything. I think I remember I solved it.
Just try compiling.
It's gonna compile on my computer. It's not gonna run on Codeforce's servers. I remember. We need this one.
Yeah, include isn't really written correctly. There's a time.
Yeah, that's why it didn't work. Maybe the algorithm was right. Whatever. Okay. We sorted the array. Array sorted. What do we do next? Tell me.
We iterate over the array to get the first.
Yes, we have the big for loop. If I only could type, life would be a dream. Okay, what's next?
Sum.
No, actually, should we?
Yeah, let's.
Sum at first.
You want to sum here?
I mean,
It's a bad idea, right? It's gonna be a square. We need to sum it some over here. This is a bad idea because we have many test cases. It needs to be 0 here. Okay, we got the sum. We got the external for loop. What's next?
Next.
We need this scary shit.
Yes, we need to calculate the elements. So, wait, F is the first. Yeah, so we just calculate the new x and the new y.
Yes. Int x1 is x minus sum minus array.
Y minus plus.
Yeah, plus array of I. F is an array of I.
Yeah.
And y1, correct?
Yeah.
Yep. Okay, now we need 2 binary searches. No, we need left and right, right?
Yeah.
to do R1 and L1 or?
R1, what's with R1?
Because we're not doing it at the same time.
Now, we are working with this scope.
Would they?
Yeah, I guess.
So we binary search. I mean, it's not sorted, so it's whatever.
What do you mean it's not sorted?
Well, the example.
Yeah.
So we binary search for the smallest one.
Okay, so we find the left border first.
Yeah.
So we need to find the first one that is bigger than x minus some, than x1. Okay. Now the thing is, there can be no one like it. There can be no number to be found, right? Like in the very first problem. So
We'll get to that when we get to that. Let's do the
let's do the general thing.
assertion and modify it. Well, when we have something in front of our eyes.
Well, what's the condition?
If array of M is bigger than x1, bigger or equal to.
Smaller, probably better to go smaller, right? If it's smaller than x1,
We move the middle. No, wait, we move the.
we move the left part to the middle, like this. And we take this one.
Now we have what we need.
Now, it's important. We have found the most right element that is smaller or equal to this.
Yeah, so that's
Or not. Or did we? Wait.
No, you haven't checked the right one, so you don't really know.
Don't we use another variable to drop? Because we're going like from first one to second one. And
Yes.
and we need to sum all of those. Like for each number, all of these correspond to pairs.
a result variable that we just increment and we find it.
We don't need the sum of the subarray. We only need the sum of two indexes.
So we each I we.
Oh, you mean to update the answer?
Yeah,
To store the answer. Yeah, you're right, right. We need it, but we need it a bit later. Let's create it, and we update it later. Okay, we're doing the tricky part right now. We're writing the binary search. So x1 and y1 are the new borders. These ones. Okay, we're searching for the left index. It means it's the first index that is bigger or equal to x.
To know that y is bigger than x, so when we start again, if we start again, then we will be starting to another
Binary search.
tree. We will begin like our leftmost index will be x1.
Yes, it's an optimization again, but it's not going to do much because it's a logarithm of moves, right? So it's, yeah, we can do that, but it's not crucial, right? That's always the hardest part with binary search, this condition. We need to very clearly understand what we're searching for here, right? So we've got some elements that are strictly less than this one, right? Bum, 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 bum. And then we need to find the last one of them, right? In the beginning, it's L. If the middle is still smaller, it's L. If it's bigger, then it cannot be L, it should be R.
Okay.
So we found in this way, we found the last element that is strictly less than x1, right? So, okay, let's store it somewhere. Left J.
I think you should check before, like you can start, but you have to check also.
You mean debug it?
No, you have to check if it's really, because in this binary search, you just check if R minus L is bigger than what, but you didn't check if X,
If there's even one exists. That what I mean? Yeah, that's true. Let's check.
Okay, I think you have to do it after each story.
Also, our initial range is wrong because we start from 0. We should start from I plus 1. And probably here we should do I minus 1. Yeah. Okay. So if the next element after hours is already strictly bigger, then
L doesn't necessarily have to be I plus 1, does it? Why yes is the question, because like maybe y is less, like maybe x is like barely smaller than the sum, so you need like the smallest numbers.
Then we checked that already before because we have it sorted and we're going one by one.
So okay, so you have that there already.
Yeah, sure.
okay. So if the next number is already bigger than x1, we put left j I plus 1. If it's not, another one? Here's this. Okay. Right. So if we have some elements in front of us that are strictly less than x1, we find the last one of them, and then we put left j L plus 1. So left j is the first element that is bigger or equal to x1. Okay, we figured that out. If I'm wrong, which I might be, we're going to see this while we try to submit it. So it's fine. Yeah, we shouldn't initialize another element. Wait a sec. Left j L plus 1. Right. Now we find the right j. Right j. How do we do that?
Say what the?
Yeah, pretty much. So if array of I plus 1 is already strictly bigger than y1, then we have no good elements at all, right? So we just gotta go. Then what do? We just continue. What does continue do? It just goes to the next iteration of the for, right? Otherwise, we do the binary search. We know that there are some elements that are smaller or equal to y1.
Why didn't you do that in the first one?
There's a different, we cannot continue here because it's not all bad. It's just that we don't need to do the binary search, but we can still add something to our answer. In this case, we add 0. So we just go forward. Okay, so left is I plus 1, R is n. Okay. Now the hardest part, the condition. If it's bigger than y1.
If it's bigger or equal to y1.
If it's bigger or equal to y1.
Because we're going.
If it's bigger or equal, it's a bad case. Like, it's some bad. Like, if it's strictly bigger, it's bad. If it's equal, it's good. So it's should be strict. Right. So if it's strictly bigger than y1, it's a bad thing. We want to cut it. So we set R to M. Otherwise, we set N to M. Yeah. Okay, so in this binary search, we found the most right index such that array of this index is smaller or equal to y1. And we do not need to plus 1 here. Notice this. Okay, so we got to this point in this for iteration.
Yeah, but doesn't that give duplicates? Because you're going over every one. So
Now, you see what we sorted it, right? And left is this one, and we go strictly, we only consider those to the right of it. And it's going to be always this way. So no duplications. Question? Nope. Good. Okay. This is the answer, right? We need to return it or print it.
What are the chances this is?
0 because there's like at least 2 bugs here. What's up? Which one are they?
So, I am the debugger now.
Right, I'm gonna like
maybe they don't say.
Run the test cases. Just
I'm gonna tell you like one of them because it's a task related thing. Look, we know that every element is like can be 10 to the power of 9, right? And at some point in the program, we sum a shit ton of them, right? So this sum can be really big.
Long.
Yeah, we're gonna get an overflow. So it will be like 10 to the power of 14, which is way too big. Which variables should be long? Answer. Yeah, right. Answer. Sure. Something else?
to be safe, we can do
Sum. No, sum. Definitely sum. Because sum is the sum of all elements of the array.
Yeah, and then the answer is the
And
sum of all sums.
no, answer is not sum of all sums.
Oh, yeah.
What is sum? How big can be sum? Or how big can be the answer? It's combinatorics, eh?
It reduces n to power 2.
True. N to the power of 2.
I mean, like you said, nobody gives a shit about memory, so just make everything one long.
No, we're not gonna do that. We're not that bad of people, right? Okay, answer some are long, and he doesn't like the library for some reason. I don't know why. God damn it! Wait, if I write algorithm, huh?
8 line from n and 7.
Yes. For your understanding, I was doing this like 4 years ago when I was in high school, so I don't remember shit.
Yeah, I get the feeling that was smarter.
Picked in high school, those vibes, right?
Yeah.
I'm now that I wasn't that, so I don't know what to tell you.
You studied biology in high school?
Yeah.
That's regrettable. I'm very sorry for that.
I loved it.
You loved it?
Loved it.
Okay, whatever works for you, yeah.
Well, it was
Actually,
a cycle, but it was quite a nice cycle, like a crowd cycle.
Is that the thing that everything evolves into now?
No.
Yeah, it is.
No. That's consensualization. I'm the Krebs cycle is the cycle that happens in plants to get energy.
The crab cycle?
Krebs was a guy.
I don't know
That
if
solves
it's
everything.
like,
No, I just remember the thing that everything evolves either to a crab or a jellyfish or something else.
evolved or devolved.
Evolved.
No, evil.
It's the most optimal shape.
Ultimate form of like a
It's like all transportation evolves to trains.
that's just factorial. No, that's
It's the
no, I swear that it's a thing. That's like
No, it is a thing.
Evolved into jellyfish.
No,
into a
yeah,
crab,
into
definitely.
a crab, yes.
okay, guys, 5 more minutes and we can talk about jellyfishes, okay? Right, we fixed the long issue.
Yes.
Let's try to submit it, right? We kind of should like,
On the test cases?
yes, but it's gonna compile for a billion years. Okay. I hate it because my computer sucks.
No, it's because JetBrains sucks.
No, dude, this guy's like 8 years old. No,
Just run GCC and then say, no, don't do that.
I hate console, dude. No.
The most unprogrammed programmer ever.
Yeah, I gotta fix that somehow. Okay.
Linux is early. It's just a matter of maintenance.
Oh, we got something very bad.
That's still like a good idea.
Let's do one test case, right? There's 7 of them here, which is hard to debug.
You need one.
Zero. We got 0. Why did we get 0? Ah, because. Oh, wait, what? No, I don't know why. Why you get 0? Something went wrong. So, what are our inputs?
We need to add 1 to left J. Because
To what?
we need to add 1 to left J.
Add 1 to left J.
Because it might make sense here, but in the context of like subtracting it.
Maybe we should just add 1 when we subtract it, right? It's an easier way.
Wait, the first one should be 0. That's for sure. Alright?
Oh, you think it's the right answer? Well, let's actually check. It should be 4.
No, shouldn't it be?
Why?
How many pairs you can do? Shouldn't it be?
Yeah. No.
12 is
Wait.
bigger than
4
10.
and 10 is.
I'm gonna.
If we add 1, we get the correct answer, so I like that. So let's see.
No, we don't. We need 4. We have 0. There's not even close.
If we add 1 there,
Yeah, if we add 1, I think we get
we
it
get the
right.
correct, yeah, because we have a for loop of 4, and then we add 1 each time. Just run this.
Actually, right. Yeah.
It works for the first one, but it's for the other cases.
Well, after this, we run the second case. And watch it just work perfectly.
But the case, like, answer is the amount of pairs per index, right?
0.
Okay, then something's definitely wrong.
We never get to this part, right? Otherwise, we would get at least something.
Yeah, so
We always hit continue here.
The array, how does it do? 4, 8, 10, 4, 6, 3.
Then 4 is the amount of items in the array.
Yeah, look. 4 is the length of the array. 8 is y. 8 is x. 10 is y. And this is the array itself.
Okay.
There is only one combination that works, which is 4 and 6. So
Yeah, I actually don't know what's wrong either. So we guys doing it together.
no.
why?
Because
Dude, have you seen how it's building? You want it to debug? Okay.
Send it on the Discord. No, that's a great idea. Send it on the Discord. No context. Just send it in general.
Yeah, not even on the cybersecurity Discord, just on like the general Discord. Okay, let's.
Maybe we messed up the formula, by the way. Let's recheck it. So, you know what the funniest thing is? When you spend all this time solving it, and then you find out that you read the task wrong. I do that all the time. Let's try this.
Wait. Yeah, there's something that's really wrong.
What's up?
You see this? There's a minus here. Where did it go?
No, because to put it here, where
Minus some plus.
Yeah, but this doesn't matter.
Yeah, you're right. Thomas is right. We fucked the math up. We always do. Thankfully, it's easily fixed, right? We don't need to rewrite the whole thing. It's not the whole idea that's wrong. So there's a minus here. What should we do?
we could just flip everything.
Yeah, we multiply by minus 1, so everything flips. This shit flips.
But doesn't it flip? Not, isn't it strictly? No, wait.
No, it's just this. This, it's gonna be minus y plus some minus f. And it looks extremely messy, and I'm gonna mess something up. This is plus.
Just we can do this.
No, it's fine.
We're going to root for then it will be
And notice that like now this is not x1. This is y1, and this is x1.
Yeah, so now we also have to.
No, it's small change. Right. So x1
So now it's
is minus y plus some.
shouldn't
Is minus y. It's probably a thing. Yeah.
Shouldn't the x is still minus one? Multiply them by minus one.
Good point. Like the same way as y. Here's
So we have some minus x minus 5f. Yeah?
minus x plus some minus.
Yeah, so some minus x minus x.
Yeah. Okay. Sum minus y minus f.
Yeah.
I can hardly see what's written over there, so you guys check me. Yeah.
Yeah, sure. And then the other one is, well, it's the same thing as y, no?
There's no f. There's array of I. Sum minus x minus f.
No, minus,
Minus array of I.
wait, what?
What's wrong?
Yeah, sure. Yeah.
All good? Okay.
Do we revert the plus one change that we did?
It was correct. I think yes.
The one we,
It was one of those two initial bugs.
right, sure, okay. Let's try it. And it's done. Use that. That is great.
Oh yeah.
Let's try the second one.
Woo!
This is pretty mature, so we're ready.
Yeah, it actually is. No, I mean little wins, right? You gotta celebrate.
Oh, we're trying the whole thing. Okay, sure.
Worse.
And on the first bit, what was the first bit was successful. So now
We do
we
everything.
have to crush our confidence.
Right.
Do everything.
470.
Yeah, it works.
Yay!
when you fuck up your math and you fuck up your program, this is like
Hell yeah.
To fuck up the math and to fuck up the logic.
Okay.
Most of the time.
Don't look at the names of my files. They are not
I mean,
children friendly. Whatever.
we're not. We're not.
Okay. I'm just submitting the C++ file to the system. You can do all this as well, by the way. Just create an account and solve stuff. Wrong answer on test 3.
what the fuck?
Yeah. No, it's how it goes, dude. It never works from the first time. Actually, we can check where it went wrong, which is usually not true. Second number is different. So some test failed. Let's not see the test itself. Let's try to just...
So we got 0 when we should have gotten a big number. So if we got 0, then we probably returned somewhere. Right. So it's probably the if condition that we did missing. So
with continue.
because if we got 0 where we should have gotten something, if we got into the whole answer, we would have gotten at least 1 in each loop. So we're probably returning each loop incorrectly. Does that make sense?
Sorry, I was not listening. I'm very sorry. Can you say again?
Because we returned 0 where we should have returned something. So that means if It's the same thing that we got in heaven.
You think it's always keeps continue, right?
Yeah, because if we got to here, we would have added at least.
No, this could have been -1 and +1 is 0, right?
Well, okay, sure. But no, but how would that have been -1? Because
I don't know.
we're returning. It's bigger.
Now, mind you, it works on the general cases. So in general, it's right. There's something very certain,
Yeah.
some
So that's why
like side case.
It's a very specific like edge case that we're accounting for. So it's probably checking that edge case. So when rate minus 1 is bigger than y, what is this?
So you were doing this in high school?
Yeah, from like 9th grade. This is a very simple thing, by the way. Yeah.
Russians.
Now you're supposed to crack this like this, and I did at some point to get a scholarship and win the thing, right? It's a very low rated problem. You see it's 1200 rated. It's really low. You need to be like 2000 rated, like 1800 right now. Back in my day, it was like more 1600. I am rated 1600. Right now, currently, I'm probably like 1000 or something. I'm really bad right now. But yeah, no, I can catch up really fast. No, it doesn't matter, okay?
And we're surprised when 11 years old,
Yeah, second year. No.
No,
it's
he's
already-
first year.
There's a couple of like middle schoolers sometimes. So just kind of, where are they from? Israel.
Here's the problem, and he's not even in high school. He's still like grade school.
Middle school, yeah. Yeah, that's great.
I hope it just like four space. That's the case. No, I'm first child.
I don't know. What?
Me?
No, right. You will think point. No.
Imagine this. Knowing if you don't do this, your whole life is ruined. I've been.
How old
I was 16.
Because it's going fucking fast.
Can we?
We can do some stuff. One thing
Wait,
is just do the test.
can you see out something when we add? Something to the answer and see if it gets to that at all.
Yeah, let's do that. Let's see the edge case first.
Browser is being checked by the FBI.
Oh no, not the browser history, dude. That was a bad joke. Okay. I think it's this one. Not good, not good. We got all zeros. It's interesting, you see, all zeros.
Just make it long. I think that's the answer. I swear to God.
Found zero. I think something is really fucked on the like big level here.
I think you need to make everything long and just.
No,
Yeah.
compensating if we need to. No. Can you see out like something when we add something to the answer and see if we get to that?
Yo, maybe we should stop here because I'm like that. I have a correct code that runs. I can send it to you in the group, and you can compare those.
Just put another wrong. I think it's just no, it's not. It's always the longer the better.
Honestly, usually it's more fun than this. Binary search is a really hard topic. I don't know why I decided. Hello.
Send to code forces.
Oh no, but we need the no. I can't.
Yeah, you can send it.
I think I will go and something.
Yeah, okay, let's just finish here. Yeah. I need to stop the recording.
Can you complete the code key?